Guys, welcome to the Pepcoding. In this video, we are going to solve this question: find first and the last position of element in sorted array. So we have given a sorted array, and we need to find a target first index and the last index if it is available in the array. If it is not in the array, we need to return -1 and -1. And we need to solve this question in log of n times. So let's see. Let's say we have a sorted array, and we need to find 2 in this array. Now for the first index and for the last index, the first index of 2 is 2, the last index of 2 is 6. Now we can find this in O of n easily. How? If we start our iteration from start, and when we get the target, we will update our first index as 2, that is the first index, and break the loop. Now for the last index, we will traverse from the last. When we get the data, we will update our last index as 6 and break the loop. So we are getting this in O of n times, and we need to solve this in log of n. So how will we do this? We have a sorted array. We can use this in a sorted array for finding any element. If we use binary search, the binary search will find the element in log of n. Now we will use this binary search for solving this question. First, we need to find the first index, then the last index. In starting, it is -1 and this is also -1. Now binary search. This is low, this is high. Find the mid. Mid is 0 plus 9 divided by 2, that is 4. Mid is here. Now at array 4, the target is 2. We have the target value, so we will update our first index. First, we are doing the binary search for finding the first index. It will be updated by 4. Now the high will be moved from here to mid -1. Why? Let's say we want the first index. We have the target value here. If we want the first index, it will be in the left side of that array from the mid part. If we go to the right, we will get the last index. So for finding first index, I will go from end to mid -1. So this high will be go from here to here. Now again find the mid, that is 0 plus 3 by 2, 1. Mid is here at 1. Now at array 1, the value is smaller than the target, so we will update our low as mid +1. Now low will be here. Again find the mid. Now mid is 2 plus 3 by 2, that is 2. Mid is at 2 also, low is also at 2. If we check the data at 2, it is equal to 2. So high will be, if we find the data, high will be mid -1. So high will go from 3 to 1. Here the condition will fail, that low is less than or equal to high, so loop will break. Now when we get this data, we will also update the data of first index. So we have the first index as 2. Now for the last index, this is 0 1 2 1 2 3 4 5 6 7 8 and 9. Now we need the last index. Low will be here, high will be here. Find the mid. Mid is 4. Now at 4 we get the data. So update the last index by 4. We need the last index. So this time low will go to mid plus 1. Because this is sorted, if we find the data, if there is another 2 available in the array, this and we want the last index, we can find the data in right side of that mid part. Now we have the mid here, low will be mid plus 1, that is there. Again find the mid. Mid is 5 plus 9 divided by 2, that is 7. Mid is here. We can see 3 is greater than 2. So high will be moved to mid minus 1. So high will be at 6 now. From 9 to 6. This is high. Again find the mid, that is 5 plus 6 divided by 2, which is 5 again. Now we have the data to update the index of last index. Move the low to mid plus 1. Mid was 5. Low will be updated to mid plus 1, that is 6. So low will be from here to here. Now again find the mid. 6 plus 6 divided by 2, that is 6. Again check the data. Data is 2. This means low will be mid plus 1 and last index will be updated by 6. So low will be at 7. Now the condition will fail and it will break the loop. By doing this, now we have the first index and the last index of the target in a sorted array. So we have achieved this in log of n. We have just used binary search for finding the data. So condition was if for the finding first index. Now if mid is equal to the target, answer at 0 will be mid. Here answer at 0 is saving the first index, and high will be mid minus 1, because we are going to find the first index. If mid is here, high will be here, that is mid minus 1. If mid is 4, high will be 3 now. Else if array at mid is smaller than target, what that means is low will be updated with mid plus 1. If the target is greater than array at mid, low will be updated. As target is smaller, so high will be updated by mid minus 1. So this is the pseudocode for finding the first index. For finding the last index, this will be changed. This will be, we are saving the answer of last index at 1 as mid, and instead of high is equal to mid minus 1, we will update low is equal to mid plus 1. This is the minor change for the right binary search. So let's code this. Now what we have is, we have n elements of array, we have a target, and we need to return an answer array of size 2, where at answer 0 it will showing the first index, at answer 1 it will save the last index. So first we need a array, answer array of size 2. Initialize this by -1. If the data is not there, it will be -1. Now we will write the left binary search for first index. Now first we need the low, then the high will be array dot length -1. Binary search, low is less than or equal to high. Find the mid, low plus high divide by 2. Now the condition, if the array at mid is equal to the target, this means we are finding the first index, so answer at 0 will be updated by mid, high will be updated by mid -1. Else, if array at mid is smaller than target, here low will be updated by mid +1. Else target is smaller than array at mid, high will be updated again by mid -1. So this is for finding the first index. Now for the last index, this will be right binary search for last index. We are moving to the right. Again update the low by 0. High will be array dot length -1. Now same code, this is the same code. There is a minor change. If we find the data, we need to save the mid at answer 1 and low will be updated by mid +1. We need to return answer. So this is the code. First we have find the first index by going to the left till the target is found, and then we find the last index. Let's run this. Let's submit this. So it is accepting all the test cases, and we have done this in log of n. So this was very easy by using binary search. If the array is sorted, we can use the binary search for finding the data. So hope you like the video. Please share the video and subscribe the channel. Thank you.